In a digital communication system employing FSK, the 0 and 1 bits are represented by this waveform and this waveform respectively. Evaluate the minimum value of the bit interval in microseconds to make these two waveforms orthogonal. So we've solved a similar question before, and we know that the integral of the product of the two waveforms must be 0 for the condition of orthogonality to be met. So we have two waveforms with frequency f1 is 6 kilohertz and the other one f2 is 30 kilohertz. So when we perform that integral, we know we end up with some two waveforms, with one having a frequency f1 minus f2, which is in this case that value would be 30 minus 6. The absolute value of that would be 24 kilohertz, and the other would be 36 kilohertz. As we've seen before, we know that those two sinusoidal waveforms must have their frequencies must be integer multiples of pi, that is sine n pi, and then after that we know we'll have one having n over tb and the other one m over tb, and in that case then we end up finding that for the minimum bit interval you will have the bit interval being the inverse of the GCD of those two frequencies. The GCD in this case of 24 and 36, that is 6 kilohertz, and then delta TB is the inverse of that, 1 over 6,000, and you end up with 167 times 10 to the minus 6 seconds. That is 167 microseconds.